Hi, my name's Jeff Christen. I'm an instructor for Cornell's Information Science Department. Last fall, I had the opportunity to participate in a pilot project introducing Amazon Web Services AppStream technology into the classroom. This short video covers 1. Goals of my Business Intelligence Systems course, which will give you some context for why AppStreams was very beneficial. Also, an overview of the BI Virtual Lab, which is the instantiation of AppStreams for my course, a quick demo of the AppStreams used by my course, and finally, a few exiting thoughts on why AppStreams brought great value to me. So, 1, just the goals of my BI course. It's intended to be a blend of both BI methodologies and technologies with a lot of just hands-on experience with some real data, serving Cornell units, building BI projects for them. So technology, methodology, and experience. All the 3 bases the students will need to help land great jobs or at least build their resumes. So methodologies covered, dimensional modeling, data analysis, ETL design development. Technologies, we chose Oracle Relational Database, Warescape Red, which is a data warehouse automation tool, Tableau, industry-leading data visualization tool, and SQL, we specifically Oracle SQL Developer. So SQL is always a good tool in the toolbox for a data analyst. Finally, we tackled projects for campus. So we used real data, came up with real solutions to help campus, but also build experience for those students. So the virtual BI lab, 2 components. One was the lab database or the class database. So we used Amazon Web Services RDS, so their relational database service, specifically Oracle RDS. Within the class database, each student had their own account with read-write access. So they had select access on a bunch of data sets that I loaded into the class database for the purpose of individual assignments and just in-class exercises. Finally, I threw snapshots of operational systems from campus to be used by the team projects. The second piece is, of course, AppStreams. That was the software delivery mechanism for the BI software used. So you'll see the combination. I already listed the apps, but the important piece is this software is very interdependent, especially the database drivers. We need all these various components to talk to the class database cleanly. This class was intended to be around data analytics, BI, design and development, not around desktop support. So this was pre-configured once, pushed out, and the students didn't have to worry about it. Now I'm going to go ahead and cut over to our live demo. Right here, this is the AppStream used by the students and by me to support the class. We all had the same image, which was very nice. So you can see the drop-down list of the software products. I already pulled each one up, just save a little time here. So here, just really quick, there's Oracle SQL Developer, pre-configured to talk to the database so they can run their queries. Next, we have Warescape. Let's pull that one up. So Warescape, again, is the data warehouse automation tool. This is a way they can quickly prototype dimensional models and instantiate them, and also create the ETL, so the extract, transform, load process to get the data from the various source systems into these nice, clean dimensional models. A better view of this, a picture is worth 1,000 words, so we'll look at some diagrams. Here's a sample dimensional model built by the students for the Cornell Diagnostic Center, actually Vet School Diagnostic Center. So it's around lab charges. So dimensional models, also referred to as star schemas because they look like a star. In the center, you'll see the fact table. The fact table is where you have all the measures for the metrics. And then around the sides, you have the dimensions. Dimensions carry the attributes that answer the who, what, where, when, and why. So there's our nice clean star schema. That's what the end user might see, the customer, or what you tie your visualization tool to. However, there's a little bit of work getting the data from the operational system into these models. So we could look at another view of the work done by the students. So we'll do a little source target diagram of just this fact table. So you'll see to drive that fact table, it actually comes from 7 different source tables in the system used by the vet school through all the various transformations along the way. So the pots and pans and mixing bowls. Then we end up with our nice fact table. That's the clean, the clean table actually seen by the customers. However, we've created the metadata along the way by using this tool, so we can always find the lineage. Where did this data come from? Now let's switch over to Tableau. You have a nice model built. So how do you deliver the data to the customer? How do you do the analysis? This is another example of work done for the Diagnostic Center. So the Diagnostic Center, they run many tests for veterinarians all over the world. They are very interested in turnaround time for these individual tests. They'd gone through some streamlining initiatives last summer, and they were interested in understanding whether the effort they went through actually paid off. So here we're doing turnaround times by the Molecular Diagnostic Center, which was the unit that underwent this streamline initiative. And you'll see over time the average turnaround, there's not a lot of fluctuation month to month. This is 2016. We go over to 2017, right around June, suddenly there's a significant drop. It's just continued drop until mid-September, which happens to be when we took the snapshot for the class, so that's why it drops off. But the good news for the director of operations for the Diagnostic Center is, hey, it paid off. Look at this, a huge reduction in those average turnaround times, so good news. Another question asked was, okay, is there any correlation between the number of tests in the pipeline and the turnaround time? So do turnaround times increase as basically the workload or the pipeline fills? Here's actually just a very simple line chart with some enhancements of color. So line chart shows, okay, 25,000 tests in the pipeline on average. And by time of day, so around, what was that, around 11. So almost noon, we're peaking, and then it tapers off by the end of the day. However, we add color. So the warmer the color indicates the longer or higher the turnaround time. So yeah, there's some, but is the correlation really the number of tests in the pipeline, or is it really more time of day? We peak right around noon, and by then you start, you get a little bogged down, and then you finally catch up. Anyway, interesting visualization. All these tools easily accessible to the students, and all due to AppStreams. Now let's flip back to our presentation. So, parting thoughts. Why AppStreams? Well, one is great way to deliver software to the students. I could pre-configure it with the driver so that it talked to the database cleanly. The focus of the course was really on usage of the technology and applying the methodology to the technology, not desktop support, so I didn't have to deal with that. So data security and product license control. We used real Cornell data for this class. We didn't use confidential data. However, it's still data we didn't want floating around. We locked the virtual BI lab down so the class database was only accessible through the AppStreams. And the AppStreams actually had dual authentication to the student. So it was locked down, only be a very clean structure. Second piece is the software for academic purposes was donated. So as long as it's used for academic purposes, that's great. Don't want the students installing on their devices and then using it on the side for other non-academic purposes. We'll leave it at that. So Similar to if we had set this up in a physical lab, we had control over the software. At the end of the semester, we could simply turn the app streams off, and then access to the software was removed. Now, the huge win, as I see it, is just the pure flexibility of app streams, which really boils down to any device, any location. You just need internet access and a web browser, and you can access our BI lab. And we really leverage that. We brought the computer lab into the classroom. I did live demos in class, 52 students, and I could project the lab, and the students could log in with their tablets, with their laptops, Macintoshes, PCs. Didn't matter. They can log in and they can follow along in their own spaces, in their app stream, hitting the database. They can follow along. Very powerful. Also for their team projects. The teams didn't have to meet in the computer lab, hope they can find enough free machines or sign up for Times Use It. Students don't have time. They have to be flexible. Here they had maximum flexibility. They could meet in the coffee shop, or I even heard stories about the students meeting, having distributed meetings. They would either get on a conference call and all log into their app stream and work through problems, or they could or video conferencing, but they could work remote. They didn't have to be in the same physical location. Very powerful. Or office hours. It just goes on and on. Very powerful tool. I'm very happy. This concludes my summary of my AppStream pilot. Thank you.